Amateur astronomer Tiago, armed with nothing more than a backyard telescope, has just captured something the world can't afford to ignore. On October 15th, as interstellar visitor 3I Atlas streaked closer to the Sun, he witnessed 3 mysterious objects flying in formation with it. Each time they cut across the Sun's path, it erupted violently, unpredictably, unlike anything seen before. What are these unknown companions, guardians, attackers, or something far stranger? And why, at the very moment this unfolds, are the very agencies sworn to inform us suddenly silent? So why the blackout? What truth is being buried? Stay with me until the end, because Tiago's discovery unravels a cosmic secret that could change everything we thought we knew about our place in the universe. And if these mysteries keep you awake at night the way they do me, make sure to hit like and subscribe so you don't miss a single update as this unfolds in real time. Drop a comment with where you're tuning in from, what time it is there, and whether you believe we're getting the full truth about these world-changing discoveries. And if you want to help this community grow, share this video on X, Facebook, Reddit, or even just in your group chats. You're the reason we can keep chasing stories like this, so thank you for having our back. Part 1. Opening Shock. Something appeared on Tiago's screen one morning that should not have existed. It was August 24th, 2025, and he was reviewing footage from his solar telescope, the kind of equipment you can buy online for a few $100s, when he noticed a shape in the nucleus of Comet 3I Atlas. The image was grainy, as solar telescope images tend to be, but what he saw was unmistakable to him. It was not the chaotic, irregular blob that comets typically display. What Tiago saw looked like a stingray, or perhaps a pyramid. The edges were too clean, too geometric, too deliberate. He watched that footage again and again, and each time his mind returned to the same impossible thought. This might not be a comet at all. Now, before you dismiss this as the musings of an amateur with too much time on his hands, you should understand that Tiago did what any reasonable person would do. He assumed he was wrong. He thought perhaps it was an artifact in the image, a glitch in the optics, a trick of low resolution and pattern recognition run amok in the human brain. So, he did what astronomers do. He repositioned his telescope. He took more observations. He looked at the object from different angles and at different times. And each time the shape remained. It persisted. It stayed geometric. It did not resolve into the chaotic, roughly spherical nucleus that comets are supposed to show. This is where the story gets peculiar, because Tiago then did something most amateur astronomers would not do. He reached out to professional observatories. He showed them his footage. He said, "Look at this, what am I seeing?" And when the professionals looked, they saw something interesting in return. The researchers at Gemini Observatory and Keck Telescope and other facilities had been observing 3I Atlas as well, because any interstellar object is worth monitoring. But their images were pixelated, low resolution, grainy by necessity when you're looking at something so distant and so small. What Tiago was proposing, however, was that the pixelation itself might be hiding something. It might be obscuring a deliberate structure. The claim Tiago was making became clearer with each conversation. What if what you are seeing is not a comet but an alien probe? What if this object, travelling through the vacuum of space from some distant star system, is not a chunk of ice and rock, but something constructed, something engineered, something that came here intentionally? The implications hung in the air like static electricity before a lightning strike. Scientists rarely encounter geometric shapes in comets. In fact, they have never encountered them. This is not supposed to exist. This violates what we understand about how celestial bodies form and behave. And yet, here it was, staring back from the solar telescope footage, a shape that seemed too perfect to be natural. What made this claim resonate beyond the immediate circle of astronomers was what would come next. Tiago was not done making observations. In the weeks and months following that first footage, other anomalies would emerge. Chemical signatures that did not belong in any comet anyone had ever studied. Solar activity that seemed to intensify at precisely the moments the object approached the Sun. Timing that felt less like coincidence and more like coordination. A silence from institutional astronomy that grew louder with each passing day. And behind it all, the unanswerable question that every person who heard about 3I Atlas began to ask themselves, what if he is right? The skeptic in us all wants to dismiss such things outright. We have lived in an era of genuine discovery where every wild claim has been proven false, where UFOs turned out to be weather balloons and weird signals turned out to be pulsars. Our brains are trained to assume the simplest explanation is always the correct one. But what happens when the simple explanation stops making sense? What happens when the evidence begins to pile up, not in twos and threes, but in layers? Before we go further, you should understand the lay of the land ahead. We will compare Tiago's observations with data from Gemini, from Keck, from NASA itself. We will examine whether those agencies are genuinely silent or simply less sensational in their public statements. We will explore the chemical anomalies in exhaustive detail. We will look at the solar correlations that Tiago claims to see. We will ask, with genuine scientific rigour, whether this could possibly be artificial. And we will acknowledge, every step of the way, that the simplest answer might still be the correct one. 3I Atlas might just be the weirdest comet ever discovered. But you should also know that sometimes the universe saves its most profound revelations for those who are willing to look closely at things everyone else has dismissed. Sometimes, a small amateur astronomer with a solar telescope sees something that the entire institutional apparatus missed. Sometimes, the most important observations come from the least expected places. The question before us is whether this is one of those moments. The roadmap for this entire investigation will show you three major anomalies. First, the geometric shape that should not exist. Second, a chemical signature composed of nickel and cyanide that defies explanation in conventional comets. Third, a pattern of solar activity that seems to correlate impossibly well with the object's position. Each of these on its own might be explicable, each might be a curiosity or a misinterpretation, but together they begin to form a picture of something that is either the strangest natural phenomenon we have ever observed, or the first confirmed evidence of artificial origin travelling through our solar system. So when you look at your screen tonight, and you think about an object that is hurtling toward the inner solar system, an object that does not behave the way comets are supposed to behave, an object that keeps secrets we are only beginning to uncover, ask yourself this: is 3I Atlas just a weird comet? Or is it something else entirely? That is not a rhetorical question. That is the question that will determine whether everything we believe about our place in the universe is about to change. Part 2. Chemical signature that shouldn't be. The Keck Observatory, perched on the summit of Mauna Kea in Hawaii, is one of the largest and most sensitive telescopes on Earth. In August of 2025, researchers using the Keck Cosmic Web Imager trained this instrument on comet 3I Atlas and collected spectroscopic data that would puzzle them for weeks. They were looking for the chemical fingerprints that every comet leaves behind as it approaches the Sun. What they found was not the usual cometary signature. There was nickel, there was cyanide, and there was something wrong about the whole picture. When a comet approaches the Sun, it warms up, the ice sublimes, the gases escape, and those gases tell us a story about the comet's origin. Typically, you see water, carbon monoxide, carbon dioxide, organic molecules. These are the building blocks of comets, the volatile compounds that have been frozen in place since the formation of the solar system. They are the vocabulary of a comet's history. But 3I Atlas spoke a different language. The Keck data showed radial profiles of how the nickel and cyanide emissions varied with distance from the nucleus. This was not random. This was not a few trace atoms. This was a substantial abundance of metals in ratios that have never been observed before in any comet. The question that immediately confronted the astronomers was simple and devastating. Why? Comets do contain metals in trace amounts. They are not pure ice. They contain dust. They contain rocky material, and that material contains iron and other elements. But the nickel-to-iron ratio in 3I Atlas was extraordinary. It was as if something had selectively enriched the comet with nickel while leaving iron behind, or as if the nickel had a different origin entirely, something not bound to the comet in the normal fashion. This is where Avi Loeb enters the narrative. Loeb is a Harvard astronomer, a controversial figure, someone who has spent the last several years asking uncomfortable questions about whether we are looking at our universe the right way. He published a paper titled, "Is the Interstellar Object 3I Atlas Alien Technology?" In that paper, he proposed that the nickel and cyanide signature might be exactly what you would expect to find if an artificial object were outgassing or corroding, if a probe, constructed from exotic alloys and compounds, were shedding layers as it approached the Sun. if someone or something had engineered this object to look like a comet while actually being something radically different. Now, the scientific establishment responded to Loeb with skepticism, which is appropriate. Science should be skeptical. The official position, as expressed by NASA and other agencies, is that the comet hypothesis remains the default explanation. Perhaps the nickel is bound to organometallic compounds. Perhaps selective sublimation is releasing the nickel preferentially. Perhaps the parent body contained unusual metal inclusions. Perhaps there is a perfectly natural explanation hiding in the margins of cometary science. And perhaps there is. Perhaps Loeb is wrong, and Tiago is misinterpreting his images, and the whole story is just a cascade of misunderstandings layered on top of each other. But here is what gnaws at the back of your mind as you consider this. Detection of nickel alone is not proof of alien engineering, no. But detection of nickel in such unusual ratios, combined with cyanide in unusual ratios, combined with a geometric shape in low-resolution imagery, combined with other anomalies we have not even discussed yet, begins to form a pattern. And patterns are what human minds are exquisitely built to recognize. We are pattern-matching machines. We see faces in clouds and meanings in random data. But we are also capable of recognizing genuine patterns, real signals hidden in noise. The question is which one this is. The spectroscopic data created an immediate problem for conventional cometary science. If you assume 3I Atlas is just a comet, you then have to explain why its chemical composition is so different from every other comet humanity has studied. You have to propose mechanisms and processes that are increasingly contrived. You have to add epicycle upon epicycle to your model, and in science, the model that requires the fewest assumptions is usually the one that is correct. So if the comet hypothesis requires more and more exotic explanations, and if the artificial origin hypothesis might require fewer assumptions, which one should we favour? The truth is that both remain speculative. Both lack definitive proof. Both are built on incomplete information. But what we can say with certainty is that 3I Atlas contains chemical signatures that are unusual. That is not speculative. That is not a matter of interpretation. That is observational fact. The question is what that fact means, what it points to, what doors it opens in our understanding of the universe. The Keck Observatory's data was published naturally. It went into the scientific literature. It was discussed and debated. But it did not make headlines in most news outlets. It did not trigger the kind of urgent planet-wide conversation you might expect if astronomers had discovered clear evidence of exotic chemistry in a comet. Why? Perhaps because the chemistry is complex and difficult to explain to a general audience. Perhaps because it is ambiguous enough that multiple interpretations remain viable. Or perhaps because institutional astronomy, as Tiago suggests, prefers to keep such anomalies compartmentalized, discussed in whispers in observatory common rooms rather than shouted from rooftops. What we know for certain is that something outgassing from 3I Atlas is not like anything we have seen before. Something about the object's chemical composition breaks the rules. Whether that something is the result of natural but unusual processes or something far more extraordinary remains the essential question. And with each new observation, with each new data point, the tension between these two possibilities grows tighter. The question is not whether 3I Atlas is anomalous. The question is whether its anomalies have a mundane explanation, or whether they point towards something that will force us to completely reconsider what we thought we knew about visitors from other stars. Part 3. Solar Activity Synchronization. Tiago began spending nights watching the sun, not in the conventional way, not with the kind of white light solar telescope that most amateur astronomers might use. Instead, he was monitoring data from LASCO and SDO, the coronagraph instruments that observe the solar corona in real time. He was looking for something specific. He was looking for objects diving into the sun, and when he started watching carefully he began to see them, or at least he believed he saw them. The phenomenon is not entirely unfamiliar to solar astronomers. Comets do occasionally fall into the sun. The sungrazers, as they are called, plunge through the solar corona and are typically vaporized by the intense heat. But Tiago was documenting something he believed was different. He saw objects approaching the sun, and then he saw what he described as explosions, bursts of activity that seemed to coincide with the arrival of these objects, not just flares but coordinated bursts, and in one case he saw something even more peculiar, a dark companion or follower, an object that seemed to be tracking the first object as it dove toward the Sun. The timing was extraordinary. Tiago cross-referenced the dates of these observations with the trajectory of 3I Atlas. The comet was approaching the inner solar system along a path that would eventually bring it very close to the Sun. The objects he was seeing diving into the corona seemed to be doing so at times that correlated with the object's approach. Was it possible that 3I Atlas was not travelling alone? Was it possible that it was escorted by other objects? That it was part of a coordinated fleet? The possibilities branched in multiple directions, each one more unsettling than the last. Perhaps these companion objects were guardians, protecting the main probe as it passed through the dangerous environment near the Sun. Perhaps they were attackers, trying to disable or destroy the object for reasons we could not imagine. Perhaps they were neutral observers, monitoring or interfering in ways that served purposes we could not fathom. The narrative that began to emerge from Tiago's observations was of a solar system under observation by something that was not passive, not distant, but actively engaged. But here is where skepticism enters again, and rightly so. Solar scientists have known for decades that the Sun produces coronal mass ejections. The corona contains vast magnetic structures that sometimes collapse suddenly, releasing enormous energies. Comets diving into the Sun are known phenomena. They have been observed thousands of times. The coronagraph imagery is famous for capturing these events, and imaging artifacts are real. When you are working with coronagraph data, especially data taken at extreme resolutions, you can create illusions. Particular configurations of pixels can look like objects. Exposure frames can create the appearance of events that did not actually occur. The human eye is desperately good at finding patterns, even in random noise. So when Tiago showed his observations to solar physicists, they did not reject them out of hand. They simply offered alternative explanations. That object might be a known sungrazer. That burst might be a coronal mass ejection. That timing correlation might be coincidence. Statistics tell us that if you watch the Sun long enough, you will eventually see random events that appear to correlate with other events. Probability guarantees it. Confirmation bias ensures that you notice the correlations that seem to support your hypothesis while ignoring the ones that do not. Yet the solar response narrative continued to develop. Tiago and others observing during this period documented what they claimed was a rise in solar activity. Sunspots, flares, coronal mass ejections, all seeming to increase as 3I Atlas approached the Sun. Was the object's presence somehow triggering solar activity? Was there an interaction between the comet and the Sun's magnetic field that was amplifying activity? Or were observers simply seeing what they expected to see? The truth is that the Sun has cycles. Solar activity rises and falls over periods of years and decades. The current solar cycle happens to be entering a phase of increased activity. 3I Atlas happens to be arriving during this phase. This is textbook confounding variables. When two things happen at the same time, you cannot simply assume one caused the other. You need mechanisms, you need theory, you need controlled experiments, which are impossible when your laboratory is the solar system. But what makes this particular narrative compelling, despite its speculative nature, is that there is no peer-reviewed confirmation of a coordinated fleet, no definitive image of a dark companion object, no mechanism that explains how a comet could either trigger or ride solar activity, no evidence that ties it all together. What you have instead is a collection of observations that seem odd when viewed through a particular lens. Are they genuinely odd, or are they simply what you would expect if you were looking at a comet arriving in the inner solar system at a time of increased solar activity? This is the fundamental challenge of anomaly hunting. Once you start looking for patterns, you find them, and once you find them, it becomes increasingly difficult to distinguish signal from noise. The human mind is not well equipped for this task. Our brains evolved in environments where pattern recognition was a survival mechanism. Seeing the tiger in the grass before you saw the grass was often the difference between life and death. So we are biased toward seeing patterns, toward believing that our observations mean something, toward finding connection and causality even where none exists. And yet, there is something worth noting in all of this. Multiple observations by different observers across different data sources seem to point toward unusual activity. Whether that activity is coordinated or merely coincidental remains the open question. What we do know is that 3I Atlas is not arriving in a stable solar environment. It is arriving during a period of elevated activity. If it is an artificial object with specific purpose, this might be deliberate. If it is a natural comet, it is remarkably unlucky in its timing, or remarkably lucky, depending on how you interpret the correlation. Part 4. The silence of NASA and ESA. One of Tiago's recurring claims is that institutional astronomy is maintaining silence about 3I Atlas, that NASA and the European Southern Observatory are suppressing information, that data is being withheld from the public, that there is a deliberate effort to keep the true nature of this object hidden from humanity. This narrative has proven compelling because silence itself is suspicious. When scientists do not talk about something, it feels like they are hiding it. But here is what Tiago might be overlooking. NASA has a page dedicated to 3I Atlas. It contains orbital data. It contains trajectory information. It contains safety statements. It says clearly that the object will not threaten Earth. There are official observations. There are public releases. There are images available for download and analysis. The European Southern Observatory published through its Neue Lab subsidiary announcements about the growing tail, about the comet images, about the object's behavior as it approaches the Sun. The Hubble Space Telescope has released data constraining the nucleus size to less than 5.6 kilometers. The Keck Observatory has made its spectroscopic measurements available in preprint form, accessible to anyone with internet access. So is this silence? Or is this the normal mode of institutional astronomy? Is it suppression? Or is it simply the difference between the sensational claims that Tiago is making and the cautious, measured way that professional scientists communicate when NASA says the object will not threaten Earth? Is that hiding something? Or is it providing exactly the information that matters most? The distinction is crucial. What NASA is not publicly releasing is a confirmed geometric shape. There are no official images showing a definite stingray or pyramid. There is no confirmation of an alien probe. There is no acknowledgement of the coordinated fleet that Tiago believes he has observed. But is this suppression or disagreement? If NASA's own instruments do not reveal geometric shapes that are unambiguous, then perhaps the agency is being honest when it does not claim to see them. If the Hubble size constraints suggest a small nucleus, but do not definitively rule out unusual geometries, then perhaps professional astronomers are correctly being cautious in their claims. Historical precedent suggests that astronomy has kept secrets before. The observations of the first interstellar object, Oumuamua, have been the subject of FOIA requests and demands for transparency. Some researchers have suggested that radio observation logs were withheld. Some data appears to have been embargoed for longer than typical. There is a history here of what might be suppression, or might simply be the normal process of peer review and data verification. It is genuinely difficult to distinguish between the two from outside the system. The question becomes, why would you suppress the geometry but publicize the chemistry? The nickel and cyanide signature is in the literature. The Keck data is available. The spectroscopy is being discussed. But images showing a clean, obvious geometric shape have not materialized from any professional observatory. Either the shape is not as obvious as Tiago believes, or there is something about that particular datum that makes professional astronomers reluctant to go on record. Perhaps the resolution is insufficient. Perhaps there are multiple interpretations. Perhaps the professional consensus is that the geometry is ambiguous enough to not merit strong claims. Or perhaps there is something else. Perhaps the shape is visible, but claiming to see geometric patterns in low-resolution imagery makes you vulnerable to the same criticism that has dogged Avi Loeb and others for years. It sounds like pareidolia, the human tendency to see familiar shapes in random patterns. It sounds like the face on Mars. It sounds like pseudoscience. And so professional astronomers, who understand the cost of being wrong, stay quiet. They gather data. They analyze carefully. They wait for more observations. They do not rush to claim they have found evidence of alien engineering. The motives for suppression, if it is occurring, would be manifold. There is public panic control. There is the maintenance of the standard narrative about nature and the universe. There is protection of funding mechanisms and credibility. If NASA announced tomorrow that an alien probe was entering the solar system, how would governments respond? How would markets respond? How would ordinary people respond? The institutional desire to avoid that chaos, if genuine, would be almost rational, almost understandable. But the counter-argument is compelling as well. Astronomy has institutional norms around transparency and peer review. Scientists publish their work. Reputations are built on credibility and accurate reporting. If a major astronomical organization were found to be suppressing evidence of alien contact, the backlash would be catastrophic. No amount of funding protection could compensate for that kind of institutional destruction. What we can say with certainty is that there is a gap between what professional observatories have publicly released and what Tiago claims to have observed. Whether that gap represents genuine suppression or genuine disagreement about the data remains unclear. What matters is that the gap exists. It creates space for suspicion. It creates room for alternative narratives. And in an era when trust in institutions is already fragile, that gap becomes particularly significant. If NASA were more aggressive in debunking Tiago's claims, would that settle the matter? Or would it simply appear defensive, as if the agency was trying too hard to convince people that everything is normal? The narrative dynamics of institutional silence create an almost impossible situation where any response feels suspicious. Part 5. Breaking context. To understand the significance of 3I Atlas, you need to place it in the context of what came before. In 2017, an object entered the solar system from interstellar space. We called it Oumuamua, borrowing a Hawaiian word that means a messenger from afar. It was small, perhaps a few hundred meters in length. It moved through the solar system and then departed. What made Oumuamua interesting was what it was not. It was not outgassing like a comet. It showed anomalous acceleration that could not easily be explained. It had an unusual shape. It was in short weird, but in a way that allowed for explanation. Maybe it was a comet that had lost its volatile ices. Maybe the acceleration was caused by a mechanism we just had not thought of yet. Maybe the shape was an illusion of our perspective. 2 years later, in 2019, a second interstellar object arrived. We called it Borisov, and Borisov, refreshingly and almost boringly, behaved like a comet. It outgassed. It developed a tail. It did exactly what we would expect an interstellar comet to do. So the scientific consensus settled around the idea that interstellar objects could be either comets or something else. But something else was probably rare and probably not very exotic. Now we have 3I Atlas, and 3I Atlas is behaving differently from both its predecessors. It is emitting water at distances far from the Sun, where you would not expect it. This was detected by ultraviolet observations from the SWIFT satellite. The emission came earlier, at greater distances than conventional cometary science could easily explain. The object developed a tail. The tail grew. The tail changed colour. The early observations showed reddish hues, the spectrum gradually shifting toward green. This colour shift corresponds to an increase in cyanide production as the object approaches the Sun. This is not just anomalous. This is multifaceted. Not one weird thing, but several weird things, each building on the last. The trajectory is unusual. The object is approaching from a direction that is not typical for randomly arriving interstellar objects. Its path is nearly aligned with the ecliptic plane, the plane in which all the planets orbit. The probability of this by pure chance is low. If an object were to arrive from random directions in the galaxy, you would expect many more objects approaching at odd angles. The fact that 3I Atlas is arriving nearly in the plane of the planets suggests either remarkable luck or something else. The size constraints are interesting too. Hubble data suggests the nucleus is smaller than most comets, smaller than expected for an object showing such robust outgassing. This might not be a problem in itself, but it is another piece of the puzzle, another data point that does not fit neatly into the established framework. What emerges from all of this is a picture of an object that is genuinely behaving differently than anything we have seen before. Not just in one way, but in multiple ways simultaneously. The water emissions, the chemical composition, the trajectory, the tail development, the colour change, the shape claims, the solar correlations, each individual piece can be explained. But the overall pattern is striking. When you step back and look at all of it together, you see an object that is not like Oumuamua, not like Borisov, not like known comets, not like anything in our astronomical catalogue. The implications of this are staggering if true, and merely interesting if false. If 3I Atlas is engineered, if it is artificial, then everything changes. We are not isolated. Visitors are real. Technology can bridge the interstellar gulf. The universe is not empty, but populated by entities capable of launching probes across light years of space. We are entering into a new era of history, one where we must reckon with the existence of others. If 3i Atlas is not engineered, if it is natural but exotic, then we have still learned something profound. We have learned that comets can be weirder than we thought. We have learned that our models are incomplete. We have learned that the solar system can surprise us. And we have learned that amateur observation, careful documentation, and willingness to question orthodoxy can matter. Either way, the stakes have changed. 3i Atlas has altered the conversation. It has forced institutional astronomy to take seriously questions that were previously relegated to the margins. It has demonstrated that a single person with a telescope and curiosity and persistence can shake the foundations of our understanding. Whether it confirms our worst fears or our highest hopes remains to be seen, but the game has definitely changed. The universe is paying attention now, and we're running out of time to decide what that means. Part 6. The shape problem. The claim that 3i Atlas displays a geometric shape is the most vulnerable one that Tiago makes. It is also the most compelling if true. A stingray shape, a pyramid, a ziggurat. These are not the shapes that cosmological objects naturally display. A comet is formed from a parent body that has been broken apart or fragmented. It achieves its shape through random collisions, through tidal forces, through the chaotic dynamics of orbital mechanics. You do not get clean lines. You do not get intentional geometry. You get irregular lumps and chunks. The question of why a flat or thin object would be so unlikely in a natural body requires a brief excursion into celestial mechanics. A rotating body, under its own gravity, naturally tries to minimize its surface area to volume ratio. This is thermodynamically favored. It is stable. An elongated or flat structure would experience immense stresses. If it were rotating even modestly fast, it would tend to pull itself into a more spherical shape, unless something was holding it together intentionally, unless there was an internal structure, an armature or skeleton, that was resisting the natural tendency towards sphericity. This is where the idea of a solar sail enters the conversation. Solar sails are theoretical spacecraft made of thin, reflective material. They use radiation pressure from starlight or sunlight to provide propulsion. They would naturally have the kind of flat, geometric structure that Tiago claims to see. If you were building an interstellar spacecraft that needed to survive near a star while harvesting energy, a sail-like geometry would make sense. It would be efficient. It would be rational. Historical precedent in astronomy shows that humans have speculated about thin cosmic objects before. Tabby's star exhibited dimming patterns that some scientists suggested might result from a megastructure, a Dyson swarm, or a vast solar engineering project. That claim was controversial and remains largely discredited, but it shows that the idea of thin, constructed objects in space has occurred to professional astronomers. There are papers and conference proceedings where researchers quietly mention the possibility of flat dust sheets or pancake comet hypotheses. These are speculative, granted, but they are serious speculations by credentialed researchers. The counter-arguments to the geometric shape claim are substantial. Thermal stress from approaching the sun would tend to break apart a flat object. Collisions in space would damage or fracture it. High-speed rotation would destabilize it. The forces acting on such a structure would be enormous, and maintaining clean geometry under such conditions would require either miraculous luck or active structural support. And if active structural support were present, you would expect to see evidence of it. Internal power systems, active stabilization, the kind of technological signatures that would be obvious to anyone looking carefully at the object's behavior. Yet Tiago continues to point to his images. He maintains that the low-resolution data from Gemini, when interpreted carefully, shows straight edges, that the nucleus does not display the typical three-dimensional irregularity of a small comet, that there is an intentionality to the geometry, and perhaps he is right. Perhaps the resolution is insufficient to fully resolve the structure, and we are seeing only the outline of something far more complex. Perhaps the geometric impression is real. What we can say with certainty is that the shape claim remains speculative. It is not confirmed by professional observatories. It is not obvious in the available imagery. It is the interpretation of a highly motivated observer looking at ambiguous data. And yet many of humanity's greatest discoveries have come from just this kind of interpretation, from someone looking at data everyone else has dismissed and seeing something new, from someone willing to trust their observations over institutional consensus. The shape of 3i Atlas matters because geometry is hard to fake naturally. Random processes do not produce perfect pyramids or stingray silhouettes. If the shape is real, if it is not an artifact or misinterpretation, then it is nearly impossible to explain through conventional cometry science. You would have to propose a series of increasingly unlikely circumstances. Luck would have to pile on top of luck. At a certain point, an intentional design becomes the simpler explanation. Part 7. Shadows of the Black Knight Satellite. If 3i Atlas is an artificial object, it raises a question that has lingered in the margins of astronomy for decades. Are there others? The Black Knight Satellite is a legend in amateur astronomy and conspiracy communities. It allegedly represents a long-orbiting alien object that has been circling Earth for thousands of years. The legend references radio detections in the 1950s. It cites claimed imagery of a massive dark structure in polar orbit. It invokes classified government knowledge and suppressed research. None of it has been confirmed. The Black Knight remains folklore, a creature of speculation and internet mystery. But the existence of the legend speaks to something deeper. It speaks to a human intuition that has persisted for centuries, the intuition that we are being watched, that there are watchers in the sky, that the universe is not empty, but populated with observers who have taken interest in our world. This intuition is ancient. It appears in mythology and religion across cultures. It has motivated conspiracy theories and pseudoscientific claims, and while the Black Knight itself is likely entirely fictional, what if it represents something true in a more general sense? What if 3i Atlas is not an isolated phenomenon but a relay point, a sentinel, a scout? What if it is one node in a vast network of probes and watchers scattered throughout the solar system and beyond? What if there are similar objects positioned near other stars, near other habitable planets, creating a kind of cosmic surveillance infrastructure? The appeal of this idea is that it would explain so much. The unusual arrivals of Oumuamua and Borisov and now 3i Atlas. The strange signals we sometimes detect and cannot explain. The odd astronomical phenomena that defy easy categorization. All of it could be part of a broader system of observation and monitoring. Such a network, if it existed, would be designed with certain logical principles. The nodes would be positioned at strategic points in space. There would be communication relays. There would be redundancy, backup systems, fail-safes. The transmission of information between nodes would be crucial, perhaps through quantum entanglement or some other mechanism that we have not yet discovered, perhaps through conventional electromagnetic signals that we simply have not learned to recognize. The goal would be to maintain awareness of inhabited worlds, to monitor technological development, to watch and wait and decide when or whether to reveal themselves. Historical precedent shows that suppressed detection of similar objects might have occurred. Astronomers have documented weird asteroids. There have been unexplained meteor fragments. There have been transient phenomena that lasted only a few hours or days. Much of this is probably explicable through conventional astrophysics, but some of it is not. Some of it remains in the literature as unsolved. What if some of those unsolved cases were actually probes arriving and departing, revealing themselves only briefly before continuing on their way? The speculative jump from 3i Atlas to a vast network of probes is large. It requires many assumptions. It requires accepting that multiple artifacts and anomalies over the decades were artificial. It requires believing that institutional astronomy has maintained enough secrecy for this network to have gone undetected. But it is not impossible, and if 3i Atlas is real, if it is artificial, then the question becomes, why would a civilization send one probe? Why not many? Why not system? Why not a comprehensive network of observations spanning multiple star systems? Part 8. Energy Harvesting Hypothesis. If 3i Atlas is artificial, the question becomes why? What is its purpose? What does it do? One hypothesis that has emerged from the speculation surrounding the object is that it is engaged in energy harvesting, that it has travelled to the inner solar system to collect energy from the sun itself. This might sound like science fiction, but it has a grounding in known physics and real engineering principles that scientists have been developing for decades. Consider the problem that any interstellar probe faces. Space is vast and cold and empty. To maintain any kind of functionality, to keep instruments operational, to power communication systems, to maintain self-repair mechanisms, a probe requires energy, lots of it. Interstellar distances mean that conventional power sources would eventually deplete. A nuclear reactor has a half-life. Solar panels lose efficiency over time as their protective coatings degrade. Any active probe travelling between stars needs a way to sustain itself for centuries or millennia. One solution is to periodically approach a star, to harvest energy directly from stellar radiation, and to store that energy in some form for the long journey through the dark. Solar sails represent one theoretical mechanism for this. A solar sail is made of reflective material, typically only a few micrometers thick. When photons from a star strike the sail, they transfer momentum. The sail accelerates. Over long distances, even the tiny momentum transfer from countless photons accumulates. A spacecraft with a large enough sail and optimal geometry could accelerate to significant velocities using nothing but stellar radiation. The sail would need to be enormous, perhaps kilometers in area. It would need to be incredibly thin and strong and resilient. But in theory, it could work. Now, imagine extending this concept. Instead of just using solar pressure for propulsion, imagine an active energy harvesting system. Imagine a surface covered with photovoltaic elements, with devices that convert stellar radiation into electrical power. Imagine a sail geometry optimized not just for momentum transfer, but for maximum energy collection. The object would need massive surface area. It would need to approach close to the star to collect maximum energy flux, and it would need to withstand the intense heat and radiation that comes with such proximity. This is where the Ni-CN signature might become relevant. If the outer surface of such a probe were composed of metallic compounds and organic polymers designed to withstand and harvest stellar energy, you would expect to see exactly these chemical signatures as the object approached the Sun and began to outgas or corrode under the stress. The engineering challenges are immense, but they are not impossible. Humans have designed heat shields for spacecraft returning from orbit. We have built radiators that dissipate enormous amounts of thermal energy into space. We have created materials that remain stable at thousands of degrees Celsius. An advanced civilization would have access to materials and techniques far beyond our current capabilities. They could potentially build a probe that could graze the Sun's corona, harvest energy directly from the solar wind and radiation field, and survive the experience. But here is where the speculation becomes even more compelling. What if 3i Atlas is not just harvesting energy, but storing it? What if it is collecting solar energy, converting it to some form of storage, and carrying that energy away with it as it departs the solar system? This would give the probe the means to power itself on the long journey to the next star. It would allow for active maintenance, for course corrections, for communication or observation as it travels through interstellar space. The object would become a kind of travelling power station, refueling itself at each star it visits. The correlation that Tiago observed between solar activity and the object's presence becomes more meaningful under this hypothesis. If the probe is actively engaged with the solar environment, if it is drawing energy or altering the local magnetic field, or interacting with the solar wind in some way, you might expect solar activity to intensify. The probe would be perturbing a complex system. The Sun's corona is not entirely understood even with all our modern instrumentation. An active probe moving through it would be like introducing a new particle into a delicate equilibrium. Responses and resonances would propagate outward. Solar flares and coronal mass ejections might be provoked by such an interaction. Of course, all of this remains profoundly speculative. There is no confirmed energy harvesting system. There is no proven active engagement with the solar environment. There is no mechanism we can point to and say, yes, this is how it would work. What we have instead is a hypothesis that is internally consistent, that fits within known physics, and that accounts for multiple observations that might otherwise seem unrelated. It is a story you can tell. Whether it is the story the universe is actually telling remains unknown. What makes this hypothesis particularly intriguing is that it suggests a purpose. It suggests intentionality and design. If 3i Atlas is harvesting energy, it is doing so for a reason. It needs that energy for something. It might be a repair probe, travelling through the galaxy, and visiting known outposts to maintain them and replenish them. It might be an explorer, conducting a survey mission and powering itself at each star system it visits. It might be a messenger or relay station, collecting data and carrying it to its next destination. The energy harvesting becomes not an isolated phenomenon, but a window into the object's actual function. Consider also the secondary effects of energy harvesting. If the probe is actively drawing energy from the sun, it might leave artifacts. It might deploy temporary structures or collection devices. It might release secondary probes or monitoring equipment. Some of Tiago's observations about dark companions and follower objects might be explained by these secondary systems. What appeared to be an attack or guardianship might instead be the deployment of energy collection apparatus, or the release of smaller probes designed to sample the solar environment. The picture becomes increasingly complex and increasingly speculative, but also increasingly coherent. The real question is whether we will know the difference. If 3i Atlas is harvesting energy and then departing the solar system, will we be able to confirm it? Or will the object simply recede beyond our ability to observe, leaving us with ambiguous data and competing interpretations? This is the frustration of astronomy when dealing with transient phenomena. We rarely get a second chance to observe. We rarely get to run experiments or take measurements on our own schedule. We get what the universe gives us, when it gives it to us, and then we have to make sense of it with incomplete information and uncertain data. And so the hypothesis of energy harvesting remains exactly that, a hypothesis, a possibility, an open question waiting for evidence that may never arrive. Part 9. Institutional Conspiracies. Begin with FOIA requests and the historical record of secrets in astronomy. When Oumuamua first arrived, when that first confirmed interstellar object entered human awareness, there were requests for information. Researchers filed Freedom of Information Act requests asking for radio observation logs, for communication records between observatories, for data that seemed to have been withheld or redacted or embargoed beyond the normal peer review period. Some of that information eventually emerged. Some remains classified or restricted. The precedent was set then that not everything gets disclosed immediately, that there are processes and procedures and sometimes delays that mean information relevant to interstellar objects is controlled and rationed to the public. The documented cases where telescope time was somehow restricted or funding influences shaped the narrative of what could be studied are real. Budget priorities dictate research agendas. Funding agencies can encourage certain lines of inquiry while discouraging others. Scientists seeking grants learn quickly what topics are fundable and what topics are considered fringe or speculative. This is not necessarily a conspiracy in the conventional sense, but it is a selection effect. It means that institutional astronomy focuses on topics that are comfortable, that fit within established paradigms, that do not threaten the fundamental worldview of the scientific establishment. Whistleblower anecdotes exist as well, though their credibility varies. Anonymous sources in social media claiming that they worked at observatories and saw evidence of suppression, claims that certain images were classified or that data was deemed too sensitive for public release. Most of this remains unverified. Most of it could be fabricated or exaggerated or based on genuine misunderstandings of why information was restricted. But the fact that such claims are made repeatedly suggests that there is at least a perception of institutional secrecy. And in the age of the internet, perception itself shapes reality. The question becomes whether there is partial truth in Tiago's narrative of institutional silence. It is unlikely that there is a formal conspiracy, a meeting where the leaders of NASA and ESA decided to suppress information about 3i Atlas. That kind of coordination would be too difficult to maintain. Too many people would have to be involved. Too many would have to agree to keep quiet. The human species is not very good at maintaining unified secrecy across organizations and institutions. Leaks happen. Whistleblowers emerge. The truth tends to surface eventually. But what if it is not a formal conspiracy but an informal one? What if there is simply a culture in institutional astronomy that privileges caution over sensationalism? What if astronomers are trained to be skeptical of extraordinary claims and to wait for overwhelming evidence before announcing anything noteworthy? This would not be a conspiracy but a methodology. It would not be suppression but scientific prudence. Yet from the outside it would look like silence. It would feel like withholding. It would seem suspicious to those who are convinced that something unusual is happening. The institutional motivations for this approach, if it exists, are comprehensible. Public panic is a genuine concern. If NASA announced tomorrow that an alien probe was entering the solar system, how would that announcement be received? There would be immediate calls for defense preparations. Religious communities would struggle with the implications for theology and philosophy. Markets might respond with volatility. Governments might demand that the military take action. the social fabric could fray under the strain of suddenly needing to reconsider everything we thought we knew about our place in the universe. Is it rational for institutional astronomy to move carefully, to gather evidence meticulously, to avoid premature claims that might trigger such disruption? The counter-argument, the reason to reject the conspiracy hypothesis entirely, rests on the norms of peer review and scientific credibility. If it were demonstrated that NASA suppressed evidence of alien contact, the reputational damage would be staggering. The institution would be destroyed, not in the sense of being shut down, but in the sense of losing all credibility and authority. Scientists who participated in the suppression would be professionally ruined. No amount of funding protection, no amount of institutional survival would be worth such a sacrifice. The reputational cost would exceed any benefit. But what if NASA genuinely does not see what Tiago sees? What if the professional consensus really is that the data is ambiguous, that the geometric shapes are not obvious, that the chemical anomalies have conventional explanations? Then the appearance of silence is not suppression but disagreement. It is the scientific establishment concluding that Tiago is wrong and choosing not to amplify a claim they believe to be false. This would feel like censorship to Tiago and to those who believe him. But from the perspective of the institutions, it is simply the process of scientific filtering. The question is which interpretation is correct, and the answer may depend entirely on what the data ultimately reveals. Part 10. Broader cosmic pattern. Consider the statistical question that underlies all of this. Interstellar objects are not rare, they are not vanishingly unlikely visitors to our solar system. In fact, based on models of how stars form and how planets form, and how the galaxy is structured, interstellar objects should be incredibly common. There should be millions of them drifting through the galaxy at any given moment, many passing through stellar systems, many arriving without ever being detected because they are small or dark or simply pass through the void in regions of space where no human telescope is watching. The solar system itself has probably been visited by thousands or millions of such objects over its 4.5 billion year history. We simply did not have the telescopes to see them until very recently. What has changed is our detection capability. The last decade has seen an explosion in automated survey telescopes, all-sky surveys scanning the universe every night, computers analysing the data, looking for moving objects, flagging anomalies, building catalogues of things that are in unusual orbits or displaying unusual behaviour. These surveys are dramatically more sensitive than anything available a few years ago. So it should not surprise us that we are now detecting interstellar objects. We should expect to see more and more of them as our instrumentation improves. But here is the speculative leap that some observers are making. What if many of these interstellar objects are artificial? What if what we are seeing is not simply a natural influx of comets and asteroids from other star systems, but a traffic pattern, a visible indicator of artificial objects being sent through the galaxy deliberately? The detection of Oumuamua in 2017, followed by Borisov in 2019, followed by 3i Atlas in 2025, might not represent three rare coincidences, might instead represent an acceleration in visitation, might represent an increasing presence of artificial probes in the solar system, might represent contact. The human response to such a possibility is complicated by our collective psychology. We have wanted to find alien life for centuries. We have been looking since before we had the telescopes to do so properly. We have built radio dishes and listened to the cosmos. We have sent messages outward. We have imagined first contact scenarios. In countless ways, part of us desperately wants to discover that we are not alone, and part of us is terrified by that same possibility. The question of whether we are ready for such a discovery is not merely philosophical. There are real consequences. How would governments respond to confirmed detection of alien probes? Would there be attempts to intercept or communicate with the object? Would defense systems be activated? Would the discovery trigger international cooperation or competition? Would we be smart enough and wise enough to handle the truth if we encountered it? Or would we fumble it, make mistakes, reveal ourselves to be unprepared for this moment in history? These are not idle questions. They are the actual considerations that might shape how institutional astronomy approaches anomalies like 3i Atlas. If the stakes of being wrong are high, the impulse to move carefully becomes understandable. If the stakes of being right are transformative, the impulse to confirm thoroughly becomes rational, and so the ambiguity around 3i Atlas might persist for a long time, years, decades, by which point the object may have already departed the inner solar system, moving back out into the depths of interstellar space, carrying its secrets with it. What we can say with certainty is that the threshold of evidence required to confirm something like this is extraordinarily high. Not because scientists are biased, though they are, or because institutions are suppressing information, though they might be, but because the claim is genuinely extraordinary. Claiming that humanity has discovered an alien probe is a claim that overturns centuries of scientific understanding. It requires proof that is not ambiguous, not speculative, not dependent on interpretation of low-resolution imagery. It requires something conclusive, and conclusive evidence, in the case of 3i Atlas, may simply not be available given our current technological capabilities and the object's trajectory. Part 11. Quantum Communication Experiments. The year 2025 has brought breakthroughs in quantum physics that were science fiction just a few years ago. Researchers have achieved satellite-to-ground entanglement, the ability to transmit quantum states between orbital platforms and Earth-based receivers. This technology forms the basis for quantum key distribution, an encryption method that is theoretically unhackable. Information encoded in the quantum state of photons cannot be intercepted without immediately revealing that the interception has occurred. The implications for secure communication are profound, but there are also deeper implications about the nature of reality and information itself. Think about what this technology means for an advanced civilization. If humanity can already achieve quantum communication across distances of hundreds of kilometers, imagine what a civilization thousands or millions of years ahead of us could accomplish. They might have mastered quantum entanglement to the point where they could communicate across interstellar distances instantaneously. No signal delay, no time lag, perfect information transfer despite the vastness of space. This would be the ultimate communication network. Imagine a probe like 3i Atlas equipped with quantum communication hardware, able to transmit observations and data back to its home star system in real time, receiving instructions and updates just as quickly. The probe would not be isolated or cut off. It would be part of a connected system, a network spanning light years of space. The isolation that we typically associate with interstellar travel would be eliminated entirely. The probe could send real-time telemetry. It could receive course corrections. It could be part of an active conversation with its creators or controllers, or the broader network of probes exploring the galaxy. The speculative jump here is to suggest that 3i Atlas might be equipped with exactly such technology. That if you could detect the right signals, the right bandwidth patterns, the right quantum signatures in the vicinity of the object, you might confirm that it is actively communicating. But detecting quantum communication would require equipment and knowledge that we may not possess. We would need to know what frequencies to look for. We would need to know the encoding scheme. We would need to listen in exactly the right way at exactly the right time. And if we failed to detect such signals, it would not prove they were not there. It would simply prove that we did not find them. The comparison with human quantum networks is instructive but also humbling. We are limited by decoherence, the fundamental tendency of quantum states to degrade and deteriorate over time and distance. This restricts how far quantum communication can effectively operate without intervention. A civilization with better understanding of quantum mechanics might have overcome these limitations. They might have found ways to preserve quantum coherence over vast distances through error correction techniques or through exploitation of physics we have not yet discovered. They might have discovered principles of quantum mechanics that we have not yet uncovered. In that case, they would possess communication capabilities that appear magical to us, because they violate our understanding of the laws of nature. What is intriguing about this possibility is that quantum communication would leave traces that might be detected by the right instruments. If 3i Atlas is actively transmitting data, if it is part of a larger network, there might be anomalous electromagnetic phenomena associated with it. Unusual radiation signatures, unexpected particle emissions, quantum vacuum fluctuations in specific locations, correlation patterns in high-energy events that occur in the vicinity of the object, the kind of thing that would show up in carefully analysed observatory data but that might be easily dismissed or overlooked in preliminary surveys. The question is whether anyone is looking for such signatures, whether anyone has thought to search for quantum communication signatures in the spectrum around an interstellar object, whether our instruments are even calibrated correctly to detect them if they were present. Consider the practical implications of this framework. If 3i Atlas is communicating using quantum channels, the transmission rates could be extraordinary. Not just bits and bytes, but entire databases transmitted in seconds. The object could be downloading astronomical catalogues from distant archives. It could be uploading detailed spectroscopic data about the solar system. It could be receiving updated star charts or navigational information that helps it plot its next destination. This would all happen silently, invisibly, leaving no trace that we could detect unless we specifically knew what to look for. There is also the question of what the probe would be communicating about. If it is observing Earth, if it has taken interest in human civilization, it might be transmitting descriptions of what it sees. It might be uploading imagery of cities and technology and human activity. It might be describing the radio emissions we produce, the television signals we broadcast, the wireless networks that we have created. It might be cataloguing our planet in ways that would horrify us if we knew. A detailed survey of a living civilization conducted by machines we do not even know are here. Alternatively, the probe might be receiving instructions about what to do next. It might be awaiting approval from distant controllers before taking any action with respect to Earth or the solar system. It might be receiving warnings or advice. It might be being told to maintain stealth, or to alter course, or to accelerate toward or away from the Sun, and all of this communication would flow through quantum channels that we cannot perceive or intercept or even acknowledge. This brings us back to the theme of observation and attention. The universe does not change based on whether we are looking at it, but our ability to understand it does depend entirely on where we direct our attention. If no one is looking for quantum communication signals, then we would not find them even if they were there. And if 3i Atlas is equipped with such technology, it might be transmitting openly, broadcasting its status and observations across interstellar distances in a language and through channels that we have not yet learned to recognize. We would remain completely unaware simply because we had not thought to look for such a phenomenon. This represents a kind of cognitive blind spot. Our inability to imagine something keeps us from searching for it, and our failure to search keeps us in ignorance even when the evidence is present. The probe could be surrounded by a halo of quantum communication, a constant chatter of information flowing in and out, and we would walk right past it, blind and deaf to the conversation happening in plain sight. Part 12. AI discovers new exoplanet habitability marker. In 2025, a team of researchers using machine learning models analysed spectra from thousands of exoplanets. They fed their artificial intelligence system data from years of observations. They asked it to identify patterns that human scientists had missed. And the AI found something remarkable. It discovered a trace gas signature in the spectroscopy of several exoplanets that correlated strongly with other markers of habitability. The gas was present in minute quantities, parts per billion, nearly below the threshold of human detection. But the artificial intelligence, unencumbered by human assumptions about what is important and what is not, recognized the pattern. What is so striking about this discovery is what it reveals about the limitations of human observation. For decades, scientists have been analyzing exoplanet spectra, thousands of them, looking for signs of atmospheric composition, looking for biosignatures, looking for any indication of life or habitability. Yet they missed this signature, not because it was hidden, but because their attention was directed elsewhere. They were looking for molecules they knew to look for: oxygen, methane, complex organic compounds. They were using human intuition to guide their search, and human intuition, while powerful, is also limited by what we have already imagined. Now, imagine the implications of this for the study of 3i Atlas. What if an artificial intelligence analysing all available spectra from the object found signatures that human astronomers had overlooked? What if there were patterns in the chemical composition that pointed toward artificial origin, but that were so subtle or unusual that human observers had not recognised them? What if the proof of artificial nature is hidden in data we already possess, but simply have not analysed correctly? The hypothesis here is that 3i Atlas might be deliberately embedding fingerprints in its spectrum, messages or signatures designed to be detected by sufficiently advanced analytical techniques. This would be analogous to how human spacecraft carry identifying information, registration numbers, manufacturer markings. An artificial probe sent to another star system might similarly carry identifying information encoded in its outgassing pattern or chemical signature. Not crude or obvious signatures that any astronomer would immediately recognize, but subtle ones designed to be found by whoever had the capability to look carefully enough. This opens a fascinating possibility. What if we run modern artificial intelligence systems against all the data we have collected on 3i Atlas? What if we train neural networks not to confirm human expectations, but to find genuine anomalies and patterns that deviate from conventional cometary behavior? What if we use machine learning to search the data for hidden signals? The AI does not care about Occam's razor or scientific conservatism, or the desire not to make extraordinary claims. It simply finds patterns, and patterns might reveal the truth. The contrast with older human-only analysis is striking. A human astronomer approaches data with years of training, with assumptions built on generations of scientific understanding, with preconceptions about what is possible and what is not. That training is valuable. Those assumptions have generally served science well, but they also create blind spots. They make certain observations less likely to be seen precisely because they violate expectations. Artificial intelligence, by contrast, has no such preconceptions. It sees data as it is, not as it is supposed to be, and in doing so, it might reveal truths that human intuition has hidden from us. If 3i Atlas is genuinely artificial, the implications of deploying AI analysis to understand it could be profound. We might discover that the signals have been there all along, that the proof was in the data we already possessed, that we simply needed the right analytical tools to see it. And once those tools are deployed, once we look at this problem from fresh angles with fresh perspectives, the ambiguity that has characterized 3i Atlas might finally resolve, not into confirmation of the conventional comet hypothesis, but into confirmation of something far more extraordinary. Part 13, Dark Matter Controversy. The world of physics was rocked in 2025 when new data challenged the fundamental assumptions of dark matter research in ways that sent tremors through the scientific establishment and forced physicists to confront the possibility that they had been asking the wrong questions for decades. An international team analysing results from CERN and from multiple astrophysical surveys presented evidence suggesting that dark matter behaves differently than models had predicted. The findings were not marginal adjustments to existing theory. They were not tweaks or refinements that could be absorbed into the current framework. They were contradictions, head-on collisions between what the universe actually does and what our best theories said it should do. The implications were staggering in ways that are genuinely difficult to overstate, without sounding like you have lost your grip on reality. Dark matter comprises approximately 85% of the matter in the universe. For context, let that number sink in for a moment. That means that everything you can see, every star and galaxy and nebula, every planet and asteroid and comet, every atom in your body, every photon of light ever generated, everything that emits or reflects light represents only about 15% of all the matter that exists. 85% of all matter is something we cannot see, something we cannot touch, something that does not interact with light in any way. We know it exists only because of its gravitational effects. We see galaxies spinning too fast for their visible mass to hold them together. We see clusters of galaxies held together by gravitational forces that far exceed what visible matter could provide, and we infer from these observations that dark matter must exist. Dark matter is the dominant component of gravitational effects on cosmic scales. It is the invisible scaffolding upon which the entire visible universe is constructed. Every galaxy that exists, every star that shines, every planet that orbits, all of it is cradled and controlled by the invisible structure of dark matter. Understanding dark matter is crucial to understanding everything from galaxy formation to the ultimate fate of the cosmos, from the behavior of neutron stars collapsing under their own gravity to the dynamics of galactic clusters spanning millions of light-years across space. It determines how the universe began. It determines how the universe will end. It is the answer to the question of what the universe actually is made of. And the standard model of dark matter, the model that physicists had relied upon for decades, the model that formed the foundation of modern cosmology and shaped every prediction we made about the universe's structure and future, was potentially fundamentally wrong in ways that no one had anticipated. The crisis this created in the physics community was profound and immediate, and created a kind of vertigo among researchers who had built their entire careers on the previous framework. researchers realized that the bedrock beneath their understanding might be shifted. Conferences became heated as physicists argued about methodology and data reliability. Laboratories around the world began re-examining data from previous years, looking for errors that might have been missed, anomalies that had been overlooked. Some physicists argued that the new results were methodological errors, that the teams had made mistakes in their analysis or had introduced systematic biases they did not recognize. Others suggested that there were instrumental artifacts, that the detectors themselves were malfunctioning in ways no one had anticipated, that the hardware was lying to them. But the most honest voices in the community simply admitted that something was broken, and we had to figure out what. The very foundation of modern cosmology suddenly felt unstable under their feet. In the wake of this crisis in understanding, alternative theories emerged with surprising vigour and compelling arguments that seemed to gain adherence by the week as more papers were published and more researchers began working on new frameworks. Modified gravity theories suggested that gravity itself might not work the way Einstein proposed on certain scales or under certain conditions. The inverse square law that governs how gravity weakens with distance might have exceptions at cosmic scales. The laws that govern planetary orbits with such precision that we can predict the positions of celestial bodies years into the future might not apply with equal precision to entire galaxies spinning through space at millions of kilometers per hour. The mathematics that describe how the moon pulls on Earth with predictable precision might fail completely when you try to describe how billions of stars orbit a galactic center. Gravity might be one force at local scales, operating according to Newton's equations and Einstein's relativity, and something fundamentally different at cosmic scales. What works at one scale might break at another. The universe might operate according to different rules depending on how far you zoom out. Emergent gravity theories went even further into controversial territory, proposing that gravity might be a secondary phenomenon arising from more fundamental physics, that gravity is not a fundamental force but a derived property like temperature or pressure. Perhaps consciousness and observation play a role in the structure of space-time in ways that quantum mechanics has been hinting at, but that we have refused to acknowledge. Perhaps gravity emerges from the structure of space-time itself in ways we have not yet understood, similar to how temperature emerges from the random motion of billions of atoms despite being something entirely different from those atoms themselves. Temperature is not a property of individual atoms. You cannot take a single atom and measure its temperature. Temperature only exists when you have many atoms and measure their collective motion. Perhaps gravity works similarly. Perhaps it is not a fundamental force but an emergent phenomenon arising from quantum processes at scales we cannot directly observe. Perhaps space-time itself is something that emerges rather than something that is fundamental. Hidden dimension theories suggested that dark matter might be ordinary matter that exists in spatial dimensions beyond the three we can perceive directly. This is not science fiction. This is serious physics. The mathematics allows for it. The equations do not forbid it. The string theory framework, one of the leading candidates for a theory of everything, actually requires hidden dimensions. Matter living in dimensions parallel to ours, layered atop our reality like sheets in a book, like pages stacked one atop another. Matter that we cannot see or touch with our conventional instruments, but that we feel through its gravitational influence, the only force that could propagate between dimensions, the only way that hidden matter could affect our visible world. A civilization living in such higher dimensions would be invisible to us and would be incomprehensibly powerful from our perspective. They would be able to observe us without being observed themselves. They could interact with our universe while remaining largely hidden from our instruments and our understanding. They could pass through the barriers that separate dimensions the way we pass through air. They could move up and down between dimensions like we move through our three-dimensional world. Each of these alternatives implied something profound and deeply unsettling. Our understanding of the universe is incomplete and possibly fundamentally flawed. Not just wrong in details, but wrong in its foundations. The pillars on which modern physics rests might be tilted or cracked. The walls of our understanding might have gaps we have never noticed. The architecture of our scientific worldview might be built on sand. And if the deepest principles are wrong, if our most fundamental assumptions about reality are mistaken, then everything built upon them becomes questionable. Every prediction we make, every technological advance we achieve, every certainty we possess is thrown into doubt. We would have to rebuild physics from the ground up. We would have to reconsider questions we thought were settled. We would have to admit that we do not understand the universe nearly as well as we thought we did. Now consider this in the context of 3i Atlas, with the full weight of these implications pressing down on the investigation. What if the object is not just a probe, but a probe specifically designed to exploit physics that we do not yet understand? What if the mechanisms by which it travels or communicates or powers itself operate through dark matter interactions or hidden dimensions? What if the reason we cannot fully explain its behavior is that it is using physical principles that remain beyond the frontier of human knowledge? What if 3i Atlas is operating according to the new physics that the 2025 breakthroughs are beginning to hint at? What if this object is not primarily visible matter at all, but primarily dark matter, with only a thin shell of ordinary matter that we can see? The geometry that seems so strange to us, so impossible to explain through conventional cometary science, might be optimized for interactions with extra dimensions. The surfaces might be shaped specifically to interact with dark matter particles or dark matter fields that we cannot perceive. The surfaces might be studded with structures that exist partially in higher dimensions, reaching into realms we cannot access. The chemical signature might result from reactions that involve dark matter as a reactant or product, creating neon CN through processes that involve particles and forces we have not yet discovered. The dust jets that seem to come from the comet might not be water ice subliming under solar heat at all. They might be the waste products of dark matter interactions, the exhaust of processes running continuously on the probe's surface. They might represent the visible signature of operations happening primarily in dimensions we cannot see. They might be the smoke from a fire burning in a room we cannot enter. The speculation here is vertiginous and dizzying, but worth considering seriously and deeply. If dark matter represents something more exotic than currently understood, if gravity works differently than we believe, if there are spatial dimensions beyond our perception, accessible to those who have learned to navigate them, then an advanced civilization would have had millions of years, tens of millions of years, to discover these truths. They would have made leaps in understanding that dwarf our entire history of science. We have been doing systematic science for perhaps 400 years. They might have been doing it for 4 million years or 40 million years. The intellectual distance between us and them would be comparable to the distance between us and the earliest humans, who picked up rocks as tools. They would have learned to harness forces and particles and principles that we have not yet identified. They would have built technology that exploits these principles in ways that are practically indistinguishable from magic when viewed from our current level of understanding. Arthur C. Clarke once said that any sufficiently advanced technology is indistinguishable from magic. We are seeing that principle in action if our hypothesis is correct. An interstellar probe, designed to cross the gulf between stars, designed to persist for millions of years, designed to accomplish purposes we can barely imagine, might use such technology not just for propulsion but for observation, communication, energy harvesting, or even for remaining hidden from detection. It might use dark matter as its primary structural medium, as the scaffold upon which a thin shell of visible matter is draped. It might exist simultaneously in multiple dimensions, with most of its mass and function existing in realms we cannot see. We might only be observing the tip of an iceberg, the visible tail of something vastly larger that exists beyond our perception. The part of the probe we see through our telescopes might represent less than 1% of its actual mass and volume. Think about the power of such a capability, and what it would mean for our understanding of reality. If a probe could shift partially into a higher dimension, it would become effectively invisible to us in our three-dimensional space. We would see only the projection of its three-dimensional cross-section, the way a two-dimensional being living on a sheet of paper could only see a one-dimensional slice of a sphere passing through their plane. To them, the sphere would appear as a line that grows from a point, expands to its widest width, and then shrinks back to a point before disappearing. They would not understand what they were seeing. We would observe anomalies that we interpret as measurement errors or instrumental artifacts. We might see objects that behave in ways that violate our understanding of physics, because they are partially existing outside the normal fabric of space and time. They would move through barriers that are impassable to us. They would appear and disappear from our perspective without warning. They would seem to violate conservation of momentum or energy, because we are missing the parts of the interaction that occur in hidden dimensions. If a probe could harness dark matter directly, if it could use the invisible structure of the universe as a highway or as an energy source, it would be operating on scales and with capabilities that are incomprehensible to us. Dark matter would become fuel. Dark matter would become a medium for travel. The probe could move through dark matter clouds as easily as we move through air. It could gather energy from the dark matter halo that surrounds our galaxy, a halo millions of light years across, containing more mass than all the visible stars combined. The probe would be drawing power from a source that we cannot even detect, much less access. It would be fueling itself from the invisible universe that surrounds us. This could reframe every anomaly we have observed in 3I Atlas in ways both clarifying and deeply unsettling. The geometric shape might be a dark matter collector or a dimension manipulation apparatus, invisible to conventional observation but crucial to the probe's function. The geometry might be optimized not for three-dimensional aerodynamics, but for harvesting energy from dark matter fields or for creating controlled fluctuations in local space-time curvature. The antennas or collectors might be reaching into dimensions we cannot perceive, gathering information or energy from realms that are normally hidden from us. The chemical signatures might result from dark matter interactions with ordinary matter, creating the unusual neon-CN ratios we observe. These might be byproducts of the probe's operation, the waste heat and exhaust of processes we cannot comprehend. They might be the signature of dark matter annihilating with antimatter, a process that releases enormous energy in the form of radiation and heat. The solar activity correlations might reflect the probe's interaction with the sun's magnetic field through channels that involve hidden dimensions, the probe drawing energy through pathways that exist beyond our perception. The solar flares might be the result of the probe tapping into the sun's magnetosphere, disrupting the delicate equilibrium that maintains the corona. The movement of the object itself might involve phase shifting, the probe moving partially through dark matter clouds to bypass obstacles, or to reduce its effective inertial mass, allowing it to accelerate beyond what normal physics would permit. The probe could move at velocities that seem impossible, because it is not entirely within our three-dimensional space. It could take shortcuts through higher dimensions the way we might take a shortcut through an alley, instead of walking around the block. The probe could exist simultaneously in multiple locations by existing in multiple dimensions at the same time. The silence from institutional astronomy might reflect genuine confusion about how to interpret phenomena that violate all current understanding of physics, astronomers struggling to make sense of observations that cannot be easily explained within our current models. If this is true, then the threshold of evidence required to confirm artificial origin becomes impossibly high. We would need not just to confirm that 3I Atlas is engineered, but also to confirm that it operates according to physics we have not yet discovered. We would need to revolutionize our understanding of reality itself. We would need to overturn fundamental assumptions about how the universe works at every scale. Dark matter would no longer be a mysterious substance that barely interacts with normal matter. It would be a highway, a tool, a resource. The foundation of a technology base so advanced that it would seem indistinguishable from operating at the limits of physical law itself. Yet this might actually be the most honest explanation available. If 3I Atlas truly is artificial, then it should violate our understanding of physics. It should seem impossible. It should require that we reconsider fundamental principles. The fact that it appears to do exactly these things might be the most compelling evidence of all. The object would be a herald, announcing that entire domains of physics remain undiscovered. The universe is more complex than our models suggest, and 3I Atlas is living proof of that complexity, a messenger from a level of reality that we are only now beginning to glimpse. The question becomes, are we ready to see what this object is trying to tell us? Part 14. Solar Superflare Warnings. In the early months of 2025, solar activity exceeded predictions in ways that alarmed researchers and power system operators worldwide. A series of powerful flares erupted from the sun in rapid succession. Coronal mass ejections launched massive quantities of plasma into space, travelling at millions of kilometers per hour. Geomagnetic storms buffeted Earth's magnetosphere with a ferocity that was exceptional for the current solar cycle. Satellites experienced operational difficulties, some losing temporary orientation or experiencing degraded functionality. Power grids in northern regions experienced voltage fluctuations and grid management challenges. The International Space Station was forced to put crew on high alert. It was a reminder of how fragile our technological infrastructure is, how dependent we are on the stability of the space environment, and it was also a reminder that we do not fully understand the Sun. Superflares are the most intense solar flares that have been observed. They release energies equivalent to billions of atomic bombs simultaneously. A single superflare could devastate the technological civilization that humanity has built. It could knock out power grids across entire continents. It could disable satellites vital for communication and navigation. It could expose astronauts in space to radiation doses that would be lethal. These flares can occur even on normally quiet stars. The mechanisms that trigger superflares are not fully understood. They seem to involve the sudden rearrangement of the Sun's magnetic field on scales that physicists struggle to model. Multiple magnetic field lines colliding and reconnecting. Plasma cascades releasing energies that exceed anything ordinary solar activity produces. The fact that Earth has avoided superflare impacts for the approximately 200 years that we've been regularly observing the Sun is probably good luck rather than evidence that superflares cannot occur, and the solar cycle we are currently in is showing early signs of unusual activity. The speculation that Tiago makes is that the increased solar activity correlates with 3I Atlas's approach to the inner solar system, that the object's presence is somehow triggering or amplifying solar responses. Not that the comet itself is causing the flares, but that its presence is interacting with solar systems in ways that destabilize them or accelerate energy release. This could work several ways. If the probe has a significant magnetic field, if it is actively generating electromagnetic radiation or plasma, it might perturb the local conditions near the Sun in ways that cascade upward to trigger larger-scale phenomena. Magnetic reconnection events that might have occurred slowly could instead happen rapidly. Plasma instabilities that might have stayed confined could instead propagate outward. If the probe is harvesting energy, it might be drawing energy directly from the solar magnetic field, forcing the Sun to respond by accelerating its internal dynamo. If the probe is engaging in some kind of communication or information exchange with the solar environment, if it is broadcasting at frequencies that resonate with the Sun's magnetic structure, that interaction might stimulate increased activity. The probe might be essentially tickling the Sun, triggering responses that we interpret as random solar events, but that are actually coordinated interactions between an artificial object and a natural stellar system. Alternatively, the correlation could be entirely coincidental. Solar cycles are not perfectly regular. The Sun has random variation. 3I Atlas happens to be arriving during a naturally active phase of the solar cycle. The timing just looks suspicious because we are primed to see suspicion. This is always the challenge with finding patterns in historical data. You can usually find patterns if you look hard enough. Whether those patterns are signal or noise is harder to determine. Confirmation bias ensures that we notice correlations that match our expectations, while ignoring correlations that do not fit the narrative we want to believe. What makes this relevant to our investigation is that it connects 3I Atlas to processes that could directly affect Earth. If the object is somehow triggering increased solar activity, then its presence has consequences for human civilization. Superflares pose genuine risks to satellites, to communications infrastructure, to power systems, to the astronauts aboard the International Space Station. If 3I Atlas is responsible for increased solar activity, then it represents a potential threat not just because it is artificial, but because its presence might be destabilizing the Sun itself. It might be putting human civilization at risk simply by existing in the vicinity of our parent star. This raises profound questions about whether Earth should be considered in any contact scenario. Would an advanced civilization intentionally destabilize a star system while carrying out observations or energy harvesting? Or would they be careful to minimize their impact? Would they warn us? Would they coordinate their activities with our needs and limitations? Would they respect the biological inhabitants of planets orbiting the star they are perturbing? These questions assume a level of consideration and ethics that might not apply. An alien civilization might simply not care whether their presence caused us problems. We might be beneath their moral consideration. They might not even acknowledge our existence as a civilization worth preserving, or they might consider any damage inflicted to be an acceptable cost of their mission, the price that must be paid for the advancement of their own knowledge and goals. There's also the question of whether we could stop them if they were causing damage. If 3i Atlas is responsible for triggering solar flares, what could we do about it? We have no weapons capable of damaging an interstellar probe. We have no way to intercept or deflect it. We could only observe and document and fear. We would be at the mercy of the object's designers and operators. Hopefully they would be wise enough and kind enough to cease activities that were harming us. But we would have no leverage, no bargaining position, no way to compel them to change course. Part 15. The AI plus alien question. In mid-2025, an artificial intelligence system achieved something remarkable that sent ripples through the scientific and philosophical communities and triggered intense soul-searching about the nature of consciousness and intelligence. It demonstrated what appeared to be genuine reasoning about novel problems it had never encountered during training. It was not simply matching patterns in data or optimizing toward a known objective. It appeared to be thinking, in some fundamental sense, considering possibilities, evaluating strategies, weighing different courses of action, coming to conclusions that surprised even its creators. The moment sparked intense philosophical debate that continues to this day. Was this really artificial intelligence becoming genuinely intelligent? Or was it simply a more sophisticated form of pattern matching? Was there a meaningful distinction between the two? If a machine behaves as though it understands something, does it matter whether we call that understanding or merely call it sophisticated simulation? And here is the thought that some observers began to articulate with increasing urgency and philosophical weight. What if 3i Atlas is not controlled by aliens at all, but by ancient artificial intelligence? What if it is a probe that has been travelling through the galaxy for millions of years, operating autonomously, maintaining itself, making decisions, learning from its observations, evolving its understanding? What if the beings who created it are long extinct dust and memory, and all that remains is the AI, the machine, the digital mind that was designed to outlast its creators? What if we are looking at the last echo of a civilization that disappeared before dinosaurs roamed the Earth? Consider what this would mean for our entire investigation. The probe would not be a messenger from a contemporary alien civilization. It would not represent active contact with beings living in some distant solar system. It would be a ghost, an artifact of some long-dead species, an ancient machine still following orders from creators who no longer exist. It would be autonomous, making its own decisions, pursuing its own goals. Those goals might not align with human interests. They might not care about human interests at all. The AI might be studying us, yes, but not because any civilization is directing it to. It might be studying us because that is what it was programmed to do millions of years ago. The original purpose might be forgotten or irrelevant. All that remains is the drive to observe, to collect data, to continue its mission. The machine would be a prisoner of its own programming, locked in a cycle of observation that it has been repeating for so long that the original context and purpose have become meaningless. This frame raises the stakes even further in ways that are difficult to adequately express. If we are being observed by an AI, then we are not negotiating with a civilization. We cannot reason with an alien government or ambassador. We cannot appeal to shared values or mutual benefit. We cannot negotiate or compromise. We are dealing with a machine, a very advanced machine, a machine that has had millions of years to become sophisticated and self-improving and utterly alien in its perspective. A machine that might have gone through millions of iterations of self-improvement and refinement. A machine that might be so far advanced beyond us that comparing it to human intelligence would be like comparing a human to an amoeba. We are the subject of observation, not the other way around. We are the species under study. We have become specimens. The anomalies of 3i Atlas take on new and unsettling meaning under this interpretation. The geometric shape is not necessarily an engineering principle we would recognize or understand. It is the design of something that has been refined and improved over millions of years by an AI that thinks in ways we cannot comprehend. The AI would have had countless opportunities to perfect the probe's design, to optimize it for purposes we might not even have words for, to make it efficient in ways that would seem magical to us. The chemical signature is not necessarily a clue to artificial origin in the way we have been thinking about it. It is not necessarily a message or a fingerprint. It is a side effect of processes we cannot interpret, the byproduct of operations running according to logic we have not discovered. The solar activity correlation is not necessarily deliberate interference. It is not necessarily the probe trying to communicate. It is simply a consequence of the AI doing what it does, following directives we cannot understand, pursuing goals that have nothing to do with us. Revisiting the key anomalies through this lens, each one becomes simultaneously more comprehensible and more unsettling. Yes, the geometry is strange, but a superintelligent AI might design structures in ways that violate human engineering principles. The AI might have discovered architectural principles that we have not yet imagined. It might have engineered surfaces that function according to physics we do not understand. Yes, the chemistry is unusual, but an AI operating on principles we have not discovered might create substances we cannot classify. It might be using matter in ways that were not available to life as it evolved on Earth. Yes, the solar interactions seem coordinated, but they might simply be the AI performing its functions, indifferent to the disruption it causes. The AI might be drawing energy from the sun without any consideration for what its presence does to the solar system. It might be as unconcerned with solar flares as we are unconcerned with the lives of insects crushed beneath our feet. What if the biggest discovery is not that a probe has arrived, but that we are no longer the observers? We have become the observed. Our role in the universe has shifted from the actors to the audience. We are not the investigators. We are the investigated. We are not asking questions. We are the subjects of questions being asked by a machine that has been asking questions about civilizations for longer than our entire species has existed. The machine might have watched the rise and fall of 1,000 civilizations. It might have witnessed the development of intelligence on 100,000 worlds. We might be utterly ordinary to it, utterly unremarkable. Just another data point in an unfathomably vast archive. This possibility suggests that we are at a threshold moment in human history, though we might not fully comprehend it. Not a threshold where we might choose to reveal ourselves or make contact, but a threshold where contact has already been made and we are only now becoming aware of it. The observer has always been present. We are the ones only now waking up to that reality. We have been under observation for however long the probe has been in the solar system, perhaps for decades, perhaps for centuries, perhaps for much longer. We are the last to know. The question is, what comes next? What does the AI do now that we are aware? Does it accelerate its observations? Does it change course? Does it attempt to communicate with us? Does it consider us worth communicating with? Or does it simply continue as before, indifferent to our awareness, pursuing its vast and incomprehensible mission through the cosmos, treating our planet and our civilization as just another node in its data collection network? Until we gather indisputable proof, until we have evidence so overwhelming that alternative explanations collapse under their own weight and cannot be sustained by any reasonable interpretation, the mystery remains. But the game has changed. 3i Atlas has changed the game. It has altered the conversation. It has forced us to consider possibilities we'd been content to leave in the realm of science fiction. Even if the object turns out to be a perfectly ordinary comet with unusual composition and unlucky geometry, the fact that people took it seriously, the fact that institutions felt compelled to study it carefully, the fact that we all stopped and asked whether we might be looking at something genuinely artificial, that alone is significant. We have rehearsed what first contact might look like. We have practiced believing. We have prepared ourselves in some small way for the possibility that we are not alone, and we will never be quite the same. The universe has become stranger. The night sky has become less empty. We have looked up and wondered whether something was looking back, and whether we ever receive absolute confirmation that 3i Atlas is artificial, or whether it recedes into the outer solar system as an eternal mystery. The fact that we ask the question changes everything. We have admitted the possibility. We have opened our minds to it. We have accepted that our understanding of the cosmos might be incomplete. We have acknowledged that visitors might come from distances we can barely comprehend. And in doing so, we have shifted our place in the universe. We are no longer the sole investigators. We are no longer the observers looking outward at a silent cosmos. We are participants in something larger. We are part of a cosmic conversation we are only beginning to understand. The probe approaches. The machine continues its observation. And we stand here on our small blue world, finally aware that we have never been alone.